Inferential statistics. This is what we can infer from the data. So, is there a relationship or difference between the data? We check the meaning of the data by checking the significance. Also, once the researcher has found whether a set of data is significant, then they can check this against the null hypothesis, or a directional one-tailed or non-directional two-tailed hypothesis. They can reject the null if there is a significant difference or relationship, or they can accept the null hypothesis if there is not a significant difference or relationship, as the null hypothesis states that there will be no change to a set of results. Researchers use statistical significance to ensure that the results can be trusted, to ensure that results collected are useful, that they didn't just occur by chance or luck. However, when conducting research, some researchers can see a practical significance within their study. This is when the results may not be mathematically or scientifically significant, but some values or information might be useful. There may not be evidence as to why they are useful. For instance, a practical significance could be a slight change in a sprint score from taking a supplement, but the change might not be a significant one, but there is still a benefit in real life. But when it comes to medical interventions, all findings must be mathematically and scientifically significant. There must be evidence as to why something has worked. This is because within medicine, the researcher can't take any risks and base their results on practical significance as this might put the patients at harm. To establish how significant a set of results are, the researcher must determine the significance by calculating the p-value. But before that, the researcher needs to find statistical data, the r-value or the mean difference value from the set of results. From this, the p-value states whether a piece of data is significant or not. The reason why the level of significance is any value must be below 0.05 is because this indicates that 5% of the data there is a risk of chance, but then 95% of the data is highly significant and can be trusted. For medical research, the level of significance might be even lower. So then only a small percentage of the data would be down to chance. Therefore, the researcher can truly trust their findings or results. There are aspects to consider and weigh up when deciding what statistical test to use to find the r-value or the mean difference. The researcher has to establish what they are testing, whether that be a correlation or difference in their data, what is the level of type of data they have, nominal, ordinal, continuous, what was their research design, was it dependent so they used the same participants for different types of tests, or was the research design independent so they used different participants for different types of tests. The researcher also needs to know if the data is normally distributed, as this determines the statistical test the researcher should use. If it is normally distributed, then they would use a parametric test, but if it's not, they would use a non-parametric test. The decision tree shown above helps the researcher decide what tests to use. Other tests such as Wilcox matched pairs, signed ranks, Mann-Whitney-U and chi-squared difference tests can be decided using the decision tree, as long as the researcher's data matches the criteria in order to use that test.